Hey everyone, welcome to yet another episode of my video series on Joshua Bloch's Effective Java, where I'll take the items that he has enumerated in this book and expound on them and try and make sense and understand what advice slash programming principles he's noted down in this book. And hopefully, of course, the reason for me to record this is as I'm trying to make sense of them and understand them, you too will learn something and gain value from it, apropos Java and object-oriented programming in general. Of course, as I usually do, I need to go through the proviso. If you already watched the previous items, you could just skip this part and save your time. But without further ado, I'll get started. Firstly, this is not a tutorial. I'm definitely not a teacher, and as I've said many times already, the more I'm learning about Java and OOP programming, the more I realize how much of an expert I'm not. Therefore, please don't think of this as a tutorial where what I say is gospel truth, so to speak. I'm pretty sure already, I'm still in item 5, but I'm pretty sure I've already made a lot of mistakes. In fact, one person commented out a few mistakes that I've made in, I think, the first item, so I'm really grateful for that. So I do request, if I do make any mistakes, please point them out, leave them down below in the comment section. I'll pin them if it's something significant, because then it's not only just for me, but also anyone else watching these videos can learn from the mistakes that I made. Think of this as the blind leading the blind. This is more of a exploratory disquisition, and I'm as blind as you are, perhaps even more. It's got nothing to do with the fact that I'm wearing glasses. It's simply the fact that I'm still very much new to Java. An analogy that I've been using in the previous videos in this proviso section is it's a lot similar to what one would do in a university tutorial setting, where we've got the tutor, of course, then we've got the bunch of students working together on a certain assignment or problem statement, trying to figure it out and make sense of it. So that's why I called it a collective exploratory disquisition. And yes, the third point, as I said, I will inevitably make mistakes. There's no way that I can get all of this right, because a lot of the concepts that he has highlighted in these books, I've never ever used them in my day-to-day job, let's say, or in my day-to-day programming. So it's all quite new to me, some of it at least. Therefore, again, sorry to keep beating on a dead horse here. Please do point them out. And given that this is a YouTube video series, given that this is a coding video series and it's on programming, it just makes sense to have all the code that I use on GitHub. So for each item, I'll break them down. I'll break the GitHub repository into different items, and you could find not only mine, but even Joshua Bloch's personal repository too that is published, in his GitHub account, which is all the code used in the book, in fact. Alrighty, let's get started. So this is gonna be item number 5. This was a very, very interesting item. I've got to be honest, the more I've learned about the dependency injection pattern, the more I've begun to appreciate it and see the beauty in the inversion of control concepts. I would say go and read Martin Fowler's blogs. He's probably the person who introduced it to the broader programming community. But Martin Fowler has some great blog posts on inversion of control. And of course, with dependency injection, normally programmers, at least I normally use it with a framework, with Spring or Quarkus, another framework that we use at work. And yeah, I've really begun to appreciate that pattern. And item 5, of course, states prefer dependency injection to hardwiring resources. Now, before we get to any of the code, let's try and get a few definitions across. Now, some people might not appreciate this, and some people might be a bit turned off by just reading of definitions, but personally, I have great admiration and I'd say even respect for words. I love language. Therefore, I do try and rely on definitions quite a lot, because I think it's a good way to get a high-level understanding before getting deeply into the code and sort of practically understanding. I think it's always good to first get a theoretical understanding, despite what some people might say, where it's all about the code and the practical understanding. In any case, sorry, I'm way too loquacious. So of course, two key words is dependency injection. Well, two key phrases would be dependency injection and hardwiring resources. So firstly, before we look at any code, let's try and understand what hardwiring resources is. I couldn't find a really good definition online. I couldn't find one that was succinct and conveyed and sort of encapsulated, that's not a programming pun, encapsulated all of what this term meant. So I ended up writing my own. And here's what I wrote down. Classes have dependencies, obviously. So if you have a class, let's say called person, or a better class, a class called employee, that class may have a dependency called class department, because that employee might be a class of that employee might be a part of a department. So in that case, the employee class is dependent on the department class. Formally, the client class, dependent class, depends on the service class for different utilities. It doesn't have to always be utilities, but in this case, it makes more sense to think of it as a utility class. And having dependencies can create tight coupling. That is true, which should be avoided in software engineering. Of course, fundamental principles in OOP programming. It can create inflexible, sorry, I shouldn't say OOP programming, it's software engineering in general, which is why we have patterns such as the microservice architecture, because we want services itself to be decoupled, not just at an OOP level. Getting back to this, it can create inflexible and untestable code if resources are hardwired by instantiating a service class and creating objects within a class. Ergo, we should prefer dependency injection design pattern. Correct. So this is the bit that we're gonna elucidate and expand on the most. The idea of why it's not a good idea to instantiate and hardwire resources in a client class if it's depending on some other utility class. So now let's take a look at what dependency injection is, because that is the solution that we prescribe to this problem we face with tight coupling. So I found this. I found two definitions. One is on Geeks for Geeks by Gurpreet Sachdeva. Here's his. I'm assuming Gurpreet. Yeah, Gurpreet is probably a bloke's name. I'm assuming. I'm assuming. Here's his definition of what dependency injection is. Just to make it easy, I'm going to call it DI, because sometimes dependency injection is kind of like a tongue twister. So I'll just call it DI. DI is a design pattern in which one object supplies the dependencies of another object. Correct. It removes the tight coupling of dependencies, so the problem we had before with hardwiring, from the programming code so that it is easy to manage and test the application. DI is also classified as a form of the broader technique of inversion of control, which is something I touched on. So the way I think of it is inversion of control is a broader principle, more of even like a paradigm in programming. I wouldn't probably put it at that level, but it's somewhere between a pattern and a paradigm. Let's think of it that way, which, again, as I said, Martin Fowler and I believe Uncle Bob. So I think those two people invented it or popularized it, introduced. And dependency injection, or DI, is more of a implementation of what inversion of control is. So inversion of control is more of a practice, a principle that one can follow, whereas DI is a more solid implementation in the form of a engineering pattern. The responsibility of providing dependencies is delegated to the external code. Correct. The interjecting code constructs the services and invokes the client to inject them. The client code need not worry about the interjecting code and how to build the services, or in some cases, even what the actual service is being used. Let me reread that. Sorry. The client code need not worry about the interjecting code and how to build the services, or in some cases, even what actual service is being used. Oh, gotcha. So because it's a reference that we are passing through a parameter in some kind of method, in some cases, we don't even have to worry about what the actual service that the client is using. So, of course, reading this definition, one thing that should remind you of is frameworks. A very popular one, or probably the most popular one, is Spring. And, the auto-white annotation, which helps us to inject dependencies into our components. And that's essentially the framework taking care of that. So there's this bit here where it says, that line right there. the responsibility of providing dependencies is delegated to external code. So this is really what inversion of control is. We are inverting the control. We're giving that control to an external party or an external framework in this case. And that's what's going on here. So the definition by Oracle Docs would be DI enables you to turn regular Java classes into managed objects. Again, in inversion of control, this management is done by the framework, and to interject them into any other managed object. Using DI, your code can declare dependencies on any managed object. So if you really think about it, what DI allows is in many ways is to follow that good old OOP principle to prefer composition over inheritance, because you will see in the example soon, the dependent class is composed from the class it depends on, and DI allows this composition to take place. So I've made a mistake here. I should type effective Java example, because these are the examples we're going to take a look at. Alrighty, firstly, let's take a look at how not to do this, how it would be done if we didn't use the DI pattern by hardwiring resources. The first approach that Joshua Bloch has given in the book is by using static utility classes, or by using static utility methods. So firstly, in the example we're going to use, there's a class called spellchecker, which depends on a class called lexicon. And that example is what we're going to use across, and eventually we're going to use DI onto that to show how it works and why it's a better option. So it's quite straightforward. Despite not being the proper way to do this, it's sort of an anti-pattern. We're doing a clear hardwiring here on line number 9. We're creating this immutable object. The spellchecker class is dependent on the lexicon class, and we're storing it in a variable called dictionary. And that's what we're using throughout this class. And we're creating this immutable object using private static final. Despite it being immutable, it's still tightly coupled because it's hardwired onto the class itself every time the spellchecker class is instantiated. Another example Joshua Bloch highlights is using a singleton. Another way people do this. It's quite similar. Nevertheless, we're still hardwiring a resource. I realize I've made a mistake here. I should get rid of the static keyword. That's where that instance of this class is given. Now, yes, there'll only be one object of the spellchecker class, but the hardwiring has still taken place. Which is why he states, neither of these approaches is satisfactory, because they assume that there is only one dictionary worth using, which is the one that we hardwire here and here. In practice, each language has its own dictionary, and special dictionaries are used for special vocabularies. Also, it may be desirable to use a special dictionary for testing. Correct. I think I might get to the testing bit a bit later, but I found a really good article or like a blog post by Spring as to why the DI pattern makes testing much more easier. In any case, getting back to this, it is wishful thinking to assume that a single dictionary will suffice for all time. So this tight coupling, again, that we touched on, makes all these assumptions, which in the real world probably won't stand. Static utility classes and singletons are inappropriate for classes whose behavior is parameterized by an underlying resource, classes like the spellchecker. What is required is the ability to support multiple instances of the class, in our example spellchecker, each of which uses the resource desired by the client, in our example the dictionary, so that's the resource. A simple pattern that satisfies this requirement is to pass the resource into the constructor when creating a new instance. And that is the solution that we shall do a deep dive into. That's happening right here in line number 16, and this here is in fact dependency injection. So we are passing that into the constructor of this class. This is one form of dependency injection. The dictionary is a dependency of the spellchecker and is injected into the spellchecker when it is created. So every single time a client's going to create an instance of the spellchecker class, the dependency is injected. We expect the client, in fact, to inject that dependency or pass it when using this class. So before we look deeply into the spell checker example in effective Java, let's take a quick look at this example I found online, courtesy of Baildung. I can never pronounce that name. I know every Java programmer uses this blog, Baildung, for work, but I know that most of us can't pronounce it. So this example here is how one would normally use DI, because a framework does it for us. So this is an example from Spring, of course. And what we have here is we have a class called FooFormatter, and we've annotated it with the component annotation. And what this tells the compiler or the framework is to put this into the dependency pool or the object graph, I believe. And then it's in the context of the application, in the application container, and all these dependencies will be created and they will exist within a given scope. Of course, the scope can change. I believe there's the application context, there's the request context. So depending on what the scope that we want, we can define how this component can live and exist. And then this foo service class is dependent on FooFormatter. And all we're doing here is we're injecting the dependency using the auto-wired annotation, and this framework takes care of all of that. So Spring really injects FooFormatter into the FooService class. Now, this is mostly how on our day-to-day we would use DI, but of course, we're not here to learn about Spring. We're here to learn about the dependency injection pattern, at least how it's defined in this item in comparison or in contrast to hardwiring resources. So here's the example we have. We have simply defined a private final variable of lexicon type called dictionary. There's no, obviously, instantiation taking place, so there's no object creation taking place. Therefore, there's no hardwiring. And then we have the constructor where we pass the dependency. So we pass the reference, the dependent object or the reference, as the client's creating an object from the spellchecker class. And then within the constructor, we set that into the private final variable within the class. So in that way, we expect the client to provide us with the implementation. We don't do the implementation. And over here, just to be safe, Joshua Block has used objects.require non-null. So what that tells us is that we can't pass a null value into this. If we do pass anything that's null, it's going to throw a null pointer exception. And that's a extra check that we pass on, that we have in this constructor. So then when the client wants to use this spellchecker class, it'll look something like this. Let me quickly demonstrate that. So if I'm going to create an object of spellchecker, I don't know why IntelliJ keeps doing that. It's kind of annoying. All I got to do is this. New, whoops. And then here I'm passing the implementation where I'm creating a new lexicon class. So that's what we are passing here into line number 16 in the constructor. And that's it. It's as simple as that. That is what dependency injection is. So we expect the client to do the implementation without doing any hardwiring. And the great thing here is now this gives the client the flexibility to pass any type of a lexicon. It could be dictionary 2, dictionary 3, it doesn't really matter. Over here, I'm just creating it on the go, but or on the fly, sorry. But it could be a different type. It could be a subtype of lexicon. There are many things that we could pass into this constructor, and that creates loosely coupled code. So he continues, while our spellchecker example had only a single resource, the dictionary, dependency injection works with an arbitrary number of resources and arbitrary dependency graphs. It preserves immutability, which is because one object exists in the dependency graph. So multiple clients can share dependent objects exactly, assuming the clients desire the same underlying resources. Dependency injection is equally applicable to constructors, static factories, and builders. Of course, because all those things are just methods which can pass values into. So just on that idea of what he mentions here, that in this example there's only a single resource being used. For an example like this, in real life this is quite rare because one class or one object generally will be dependent on many other objects. In a case like that, it's much easier using a framework because then all you got to do is use auto-wired or inject or any other annotation depending on the framework and let the framework take care of it by inversion of control, let's say. And then we're given an example of how the DI pattern has been used in the Java utils library. In fact, it's used. The example he's given, it's for functional programming. He says a useful variant of the pattern is to pass a resource factory to the constructor. A factory is an object that can be called repeatedly to create instances of a type. We shall see soon a good example of it. Such factories embody the factory method pattern. Before we continue, let's quickly get a quick definition of what the factory method pattern is. Probably one of the most popular patterns in OOP, design patterns in OOP. Factory method is a creational design pattern that provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. This is from Refactoring Guru. So I'm not going to go deeply into what the factory method pattern is, but essentially it's a pattern that's used when creating objects, and it sort of makes sense to use DI or a variant of DI in the factory method pattern, because what we're really doing here is creating objects. So the example Joshua Block has used is the supply interface that was introduced in Java 8 to implement functional programming. It's a part of the Java utils function package. And what this really allows us to create objects in a functional way, or in a functional programming paradigm. What a client can do is pass in a factory, which is this supplier, to create a subtype of the specified type via the generic. Because if you go to the example, in fact, okay, so a really good example I found is in this article by, who's written this? Someone called Pasil53. Okay, I haven't got a proper name. It's just a pseudonym. Anyway, this example here is really good. It explains what the supply interface does. So what it allows is it uses a wildcard. So it uses something called bounded wildcard type. In fact, before I get to explaining it, let me quickly read this paragraph by Joshua Block himself. So methods that take a supplier, so that would be this method here, the create method. I'll read that again. Methods that take a supplier on input should typically constrain the factory's type parameter using a bounded wildcard type. And that's what we're doing here, the bounded wildcard type. What this really means is this generic type we are passing into this method, into this supplier, it should be a subtype of tile. And that's why it's called, so the upper bound of that is tile. And that's why it's called bounded wildcard type. So generally the highest upper bound of something would be object, because everything is a subtype of object in Java. But in this case, any type that we pass here should extend or be a subtype of tile. So it's really a constraint, as Joshua Block has delineated on the book, using this bounded wildcard type to allow the client to pass in a factory that creates any subtype of a specified type. Simply what the tile factory is an object that can be called repeatedly to create instances of type tile. And then another example, which I was showing here, this blog post by this random person on Geeks for Geeks, is much clearer than the one, in fact, Joshua Block has given in the book. So, at least to explain what the supply interface does. So, over here, we have a supply, and we're saying its type is double. And we have this random value variable that we're creating. And then simply what this does is it creates an object every time it's called. And then the only thing the supply interface contains is one method called get, which allows us to get the object that we create using the get method. So yeah, the point that he's trying to make in the book is that this supply interface is a variant of the dependency injection pattern being used, in fact, in a factory method pattern. And then he continues, although dependency injection greatly improves flexibility and testability. So that now I want to get to this article on Spring. I would leave a link to this down below in the description. It's a great article. I highly recommend you reading it. You'll see the value of using DI, especially when it comes to testing. Now, I've personally had the experience of appreciating DI, especially in the context of things like Hibernate, using ORM tools that made testing much easier with JUnit in Java. So therefore, I highly recommend you read this article. It's well worth a read. So I'll read that again because I keep interrupting myself. Although dependency injection greatly improves flexibility and testability, it can clutter up large projects, which typically contains thousands of dependencies. This clutter can be all but eliminated by using a dependency injection framework, such as Dagger, Juice, G-U-I-C, never heard of it, and of course Spring. So that's kind of what I mentioned before. Over here, there's only one dependency, but generally in large projects, that's not the case. There are many dependencies. In that case, it just makes sense to use a framework. And then we finish it off by Joshua Block saying, in summary, do not use a singleton or static utility class to implement a class that depends on one or more underlying resources, that would be hardwiring, whose behavior affects that of the class. And do not have the class create these resources directly, as we saw in the anti-pattern examples. Instead, pass the resources like that, or factories to create them, into the constructor or static factory or builder. This practice, known as dependency injection, will greatly enhance the flexibility, reusability, and testability of a class. That's it. It's quite a simple item, but it's ubiquitous. This pattern is ubiquitous in Java programming, and I think especially using it via framework as a client, we would be clients in that case, we will start seeing its value. Therefore, it's something that's worth diving deep into and trying to understand. That's it. Thanks for watching. I hope you found value in the video and enjoyed that. And really, I do hope that I'm getting a bit better at making these videos, because sometimes, as you can clearly see, I struggle, one, to code live, but also two, to articulate some of these concepts in my own words. But hey, it's a process. It's a journey that counts, to use a terrible cliche. Thanks for watching. Cheers.